Our presentation is called Humanizing Heat Experiences Through an Open Source Data Approach. And Matthew, Liv, and Tom will be joining me today. So an overview of our presentation, we're going to talk about Heat Story, which is a really incredible project that Liv Yoon was the principal investigator on, why this project started, why it's important. We're going to talk about how we've adapted that project to work on the Environment and Health Data Portal, which is part of the NYC Health Department. Tom's going to talk a little bit to us about the technology side of things, and then we're going to demo the prototype, not quite ready, but almost there, and then let you know how you can get involved.
Okay, so I will preface by saying that I am definitely not the tech guru here. I will leave that for Tom and Matthew and Emily afterwards. But I'll provide some context for why we did this project in the first place. And to do that, of course, we need to start with climate change. So we all know that climate change is bringing more intense and frequent and longer lasting heat waves each year. And for New York, it's projected that by the year 2080, there might be 6 times as many 90-degree days and more, and 90 degrees and higher, and 5 times as many official heat waves in New York City. And a place like New York City will be hit harder because of something called the urban heat island effect, which is the phenomenon of cities being hotter than surrounding rural or suburban areas. And this is because cities have more things that absorb and trap heat, like asphalt, concrete, brick, dark roofs and pavement. There's also taller buildings densely together, of course, higher traffic and carbon-emitting infrastructure, and, of course, a lot more people using energy all at the same time. Why is this exactly a problem? Well, it's literally an issue of life or death. So extreme heat kills more Americans each year than any other weather-related event. So it's more than floods, it's more than hurricanes, and it's a silent killer, right? Because we can't exactly see heat, although, through our project, what we're trying to do is visualize heat. So as is already, heat kills about 350 New Yorkers prematurely every year. And these deaths have been increasing over the past decade. And researchers at Columbia found that by the year 2080, up to 3,300 New Yorkers could die each year from intense heat waves that's, of course, becoming worse every year by climate change. But what's equally important here, what's more important here is that not everyone or every neighborhood is affected equally. So Black New Yorkers are more likely to die from heat stress, with death rates 2 times higher than among white New Yorkers. And heat-related death rates are also higher among people in poverty, seniors over 60, and those with other chronic health conditions. And people in poverty or socially isolated are also more likely to die from heat. And this, when I say material deprivation, it's not just poverty, of course, but that is the overall arching context, but also includes minor things like access to air conditioning, which turns out to be not so minor. And this isn't just about having air conditioners, but also having actual full control over it. So, a lot of tenants who rent, they don't actually have control over operating their AC. So it's not just about possession. And also people living in historically redlined areas, which means that these areas weren't really invested in. They were literally redlined as areas not worth putting in public infrastructures in. So this, what that's led to is that these areas have fewer trees and green spaces, but they have higher concentration of heavy industry and traffic. So things that usually aren't, sought after infrastructure in communities. And of course, it's not a coincidence that all of these things overlap. So even within an urban heat island like New York City overall, Manhattan or the South Bronx, there are hot spots in particular, and that's what we wanted to explore, these hot spots within an urban heat island. And knowing that all of these other disparities I just mentioned are more prevalent in areas like northern Manhattan and the South Bronx, we decided to look more depth into these areas. So these are photos of the South Bronx. So the two on the left, that's the South Bronx on the top, and that's northern Manhattan on the bottom. So you can see there's a lot of asphalt, not many trees. Compare that to the photo on your right. So these are photos of the Upper West Side and Upper East Side. So to allow for comparison, we also included the Upper West and Upper East Sides, knowing that these areas have very different demographics compared to the northern Manhattan areas and the South Bronx. and do not have the same disparities. To sum up, the reason we chose Northern Manhattan and the South Bronx is because we know that these areas are strife with all the disparities that I mentioned in the previous slide. And we also included these other more wealthy, whiter areas for comparison. So how did we actually make this happen? So for a while now, there's been a nationwide campaign each year in the States, part of the National Integrated Heat Health Information System, NIAS, jointly developed by NOAA, so that's the National Oceanic and Atmospheric Administration, and also the Center for Disease Control and Prevention, so CDC. And they partnered with Kappa Strategies in Oregon, and that's climate adaptation and protection, and they're like a research consulting company. So we applied for this campaign and fortunately became one of the 12 cities participating in the 2021 iteration of the heat mapping campaign. So what was really integral here was that this was a community-based participatory research project. So recognizing that community members had the expertise here, for instance, which routes to measure, because we traversed along 10 different routes. So I'll explain that more in depth. Knowing that they had the expertise here, we researchers from Columbia, like myself, joined forces with community organizations. So in our case, South Bronx Unite, and they were absolutely pivotal here. So we asked South Bronx Unite and also other environmental justice organizations like We Act in Harlem and also community boards in the area, so in Northern Manhattan and the South Bronx, to tell us which areas were hotspots of concern. So we wanted to, we didn't want to just randomly designate what to measure, but we wanted to know specifically where the corridors of high activities were, because ultimately we're interested in how heat impacts people. So we wanted to identify which are areas of specific concern. And of course, community members are going to know a whole lot better because they have expertise around lived experience. And with these points of interest collected from community members, we sent them to Kappa Strategies and they designed the driving routes. So the rightmost photo here, those are the traverse routes that you see. So we had 10 different routes. And then we were in conversation with NOAA, the National Oceanic and Atmospheric Administration, and the National Weather Service to pick a date that qualifies as an extreme heat day. So that day for us ended up being July 21st, 2021. And on data collection day, there were 10 different routes. One of them was a cycling route. So people would go out in pairs and drive along this 1 hour route 3 times a day. So at 6 a.m., 3 p.m., and 7 p.m. So, at 6 a.m., there'd be 9 pairs going on 9 different driving routes and 1 cyclist doing the cycling route. And then we would repeat that twice more during the day. So what you see in the middle there are the sensors. So these are called Type T thermocouples from Kappa Strategies, and they fired off every second, and they captured block by block differences in heat and humidity. So we really got granular data, and we ended up with over 43,000 data points. And we had over 43 community members participate in this, and they were, of course, compensated for their time. And again, community expertise was really important here because, when we first look at Google Maps and think about what routes are important, we might avoid areas where there are ostensibly parks, but, community members told us that these so-called parks, some of them are just concrete slabs with a swing set and not really, covered with vegetation that's actually good for heat. So it's this type of knowledge that it was really, really valuable to get from community members. Okay, so I will pass this on to Emily now in terms of how this came together with a New York City team to make Heat Story.
So I'm just going to talk about the process of bringing Heat Story onto the Environment and Health Data Portal. So beginning to collaborate with Liv and Tom to bring this interactive heat mapping project onto the Environment and Health Data Portal is just another asset on this resource that helps connect the environment and your health. So just a little bit of background on the Environment and Health Data Portal. It has hundreds of data sets on all the things that make up our environment, such as air and water quality, but also things you might not think of when you think of the environment, like bike lanes, park access, tree coverage, socioeconomic data like neighborhood poverty, and the outcomes that comprise our health, like asthma emergency department visits from air quality, heat stress deaths and illness, et cetera. This is all very useful, and many of our colleagues, researchers, community organizations, and advocates Students, teachers, and interested folks use our data to understand the neighborhoods that they live and work in. But we try to go beyond the data because we know that seeing a table or a chart alone doesn't always tell the full story. In fact, it seldom does, which is why we include narratives and interactivity whenever we can to help make key takeaways from our data clear. These are a few screenshots from some data stories that we did relating to today's topic, which is extreme heat in New York City. The second chart here shows air conditioning access and how it varies by neighborhood. The red dots have less access than the New York City average. The blue dots have more access than the New York City average. Air conditioning use, which, as Liv mentioned, means not just having access to it, but also being able to afford to use it and operate it, is the biggest intervention there is in terms of preventing heat-related illness and death. And in New York City's lower income neighborhoods, AC use drops quite a bit lower than in higher income neighborhoods, from about 90% to about 76%. So Heat Story naturally fits in with this type of explanatory content that we like to produce. It uses data visualizations and clear narrative to make an impactful point. But Heat Story goes a step further and includes personal stories, which is something these data sets so often lack a connection to. So how we did it, which Tom will get a little bit more into the technical details. So we were in luck. Heat Story was initially created using many of our data sets already. These are available for anyone to download and use. The original version of Heat Story used a static version of our data, but this meant that it couldn't be updated. So if we got, for example, a New Year's worth of data, Heat Story, the tool wouldn't necessarily be linked back into that data, and it might remain outdated. So what we were able to do was pull from an existing bit of code that we had that would update our content whenever we got a new data set. And Tom reworked this to update Heat Story using our data. So now that it lives on the portal, whenever we update our data, the map layers on Heat Story get updated too. So now I'll touch on how using an open source approach benefited this type of public-private partnership. So we publish our data on GitHub. We make sure our data is publicly available and usable in an accessible way. We made changes to our page on our repository, and then Tom would open a pull request into a forked copy of our repository. And then, we would see his changes, and it would kind of continue on like that. And we had many iterative meetings, demos, and collaboration using our skills tools and shared vision for the project. This is not always how government tech operates. Sometimes these projects can take a really, really long time. Using open source tools like GitHub, VS Code, et cetera, enabled this form of collaboration to take place relatively quickly and easily. Our skill sets were complementary, but not always exactly the same, so we needed to adapt the project for our product, which meant reducing the amount of data sets visible, limiting to the New York City area. Some of the data was in New Jersey previously, and as the New York City government, we can't go outside of that when we represent things, and we had to change some things around language and content standards. However, overall, this process was supported by so many things. Our shared goals around creating useful, accessible civic tech, our many existing products and data sets on the portal around heat vulnerability and equity, such as the Heat Vulnerability Index, the Heat Mortality Report, which we release each year, and a technically capable team of people with backgrounds in research, writing, coding, web development, software development, and more. This made the project a natural fit to increase engagement and going beyond the data to make the problems the data was indicating to us feel grounded in the impacts that real people are dealing with every day. So this is just a screenshot of what Heat Story is looking like as we're developing it. You can see in some of these layers, there are the redlining maps, which Liv talked about. These were 1930s era maps that show how racist housing policies continue to have an impact on neighborhoods today. You can see that the neighborhoods that are red or have a grade of D, which was distributed to almost any neighborhood with Black residents when the policy was active, has some overlap with higher rates of heat stress hospitalizations. You can see this up near the Bronx in the Highbridge and Concourse community districts. You can also see there's a neighborhood poverty layer, and we can observe some similar disparities when we look in that area as well. And this is an example of one of the stories. So we can see this layer of the map includes the community science sensor data that Liv was referring to, collected for the Evening Heat Index around northern Manhattan. On the left, we can see a personal account about how between the heat, traffic, air pollution, and odors, which we've all experienced in the New York City summer, our story submitter was feeling exhausted in her neighborhood, which had a lack of shade trees. In her submitted picture, we can see the lack of tree coverage and all of the cars baking in the summer sun. And on the right, we can see in the accompanying heat index that certain blocks are several degrees hotter than others. So now I'm going to turn it over to Tom. He's going to talk a bit about the process of bringing Heat Story onto the New York City Health Department website. And then I'll do a quick demo for you guys.
Awesome. Thank you, Emily. I'll just do a quick introduction of myself. I'm Tom Zincraft, software developer by day and volunteer software developer by night and weekends. I've gotten involved in a number of volunteer software things. I saw a number of developers in the comments, so this is definitely something that's out there if you go looking. USDR is one that I'm part of, US Digital Response and DataKind. I did a little stint with as well. These things are out there. They're very cool to do, and I'm very excited to be talking at Open Data Week with Beta NYC because it's like they're very much on this mindset. I like how we can use civic tech and how we can mix that in with governments. For anyone that's interested in, there's Jennifer Palka wrote that great book recently. This is something we're seeing more and more of, so it's really exciting to be part of this sort of environment. Originally, how I got into this project was through the Jersey side. So Jersey City did the exact same sensor project that Liv was talking about. We opened a website to combine Jersey City and New York City that we'll talk about a little bit. That's how this project got started. And then, oh, excellent. Thanks, Matt. So Matt put in the comments the book. It's excellent book. So we did the same sensor project, got the same data. One of us on the project on the Jersey side reached out to Liv, and we started collaborating to make this Heat Story. We had a website for it. The website was very cool. I'll talk about the technical stack to that website as well a little bit. And then from there, we ended up just collaborating for a while. We saw the website for the Department of Health, and we decided to reach out, and we were able to do this collaboration. Thank you. So we're going to talk a little bit about the tech stack. I don't think I mentioned it here, but the tech stack for the original website was actually Svelte. Me and my friend that were working on it decided to try something a little out of our wheelhouse. It's always very cool with these projects to try something a little new. For anyone who's used Svelte, very cool web framework, very fast, very easy to develop in. For this one, a lot of the web stack was already built for us. Thanks to the great team over at New York City. They were using Hugo, and I have to say, it's one of the few projects I've been able to pick up, and everything just works. Hugo has been very cool. It's a static site generation framework. It's not really like any JavaScript framework. If for any developers here, it's not like React, right? We're not no Vue, none of that stuff. I assume you can integrate it, but for this to be as extensible as possible, it was just a plain JavaScript. Something that you didn't see for many years, but is actually making a little bit of a comeback, just seeing non-React JavaScript out there. So we were able to write this with all just plain out-of-the-box JavaScript. For the visualizations, there are other parts of the website that use something called Vega. For this one, we had originally used Leaflet. I saw some GIS developers on the call. Leaflet, if you haven't used it, is amazing. Leaflet is one of the best open source, is the best open source library for mapping. Mapbox used to have an open source library, but they have since closed source. For anyone interested in that, I could talk about the whole environment for a while and how open source has shifted over the years to cause stuff like that, but not the talk for that. So we use Leaflet. Leaflet is very extensible, really nice framework, actually written by someone in Ukraine, I believe. All of the data, so there's no database behind this either. It's amazing what you can do with just some open source tools, like really just using GitHub to host your data. The original version used data hosted in GitHub. And so I can answer that question real fast. I see Norton asks, how do we do ETL? There is no need for ETL for this. So the process is all of the data sets are pulled dynamically through the GitHub Open Data Portal. So if you were to look up the EHDP data, there is a GitHub with all of the data in JSON files. We actually pull that directly from GitHub. GitHub does have limits when it comes to how much data you can fetch. The rate limiting, though, is we would need a lot more traffic in order to hit the GitHub rate limits for that. And then if you do, you can put a CDN in front of it and everything's fine. So we pull all the data dynamically from GitHub. All of that gets published by the New York City Department of Health, or I assume, actually, I guess Matt and Emily can talk more to who publishes it. I'm purely assuming there. But we wrote these wrappers to be able to fetch that data, and all of our wrappers are configuration driven. So people that are working on this project can actually update a configuration using just some names of data sets and some IDs, and it'll dynamically fetch the data sets as they get added to that GitHub process. For the heat stories themselves, the heat stories get submitted through a Google form. And then once the heat story is on there, the same configuration configures all of the HTML for the stories. And once those get added, a simple reload of the website will then dynamically load up those new stories, including things like HTML images that we could also host on github.com. It's a really cool stack. Databases are very complex, and this reduces that complexity a lot. So we were really happy with this approach. There's a number of data sets. This just highlights a few of them. The heat vulnerability index is scale of 1 to 5. I'm going to skip over to like vegetative cover, green spaces, AC access, redlined areas, heat stress hospitalizations, and PM 2.5 concentration. These are all very cool data sets that are available on that GitHub that got chatted out. These are all open source. They're really easy to use. Most of these, they're just basic JSON format. I think I had to convert them to GeoJSON to be used with Leaflet, but that conversion was really easy to do. And a very cool part of this project was actually being able to contribute the code that converted those data sets to the GeoJSON format so that it can be used with other Leaflet maps. That was a very cool thing that we did, so that now if you're using your own project that uses GeoJSON or that uses Leaflet or Mapbox, you can actually leverage that code to take these exact same data sets and put it right into your map with a little bit of customization. The last data set on here that was not part of it is the heat indices. This heat indices was available, and it is actually open data as well. Kappa releases all the data for all their different projects. That actually comes as a few files. There are the raw calculations so that you can get the actual data points, those 43,000 data points, exactly the GPS location and those values. Kappa also releases as a TIFF, which is basically an image that they overlay onto maps. They release that using their machine learning algorithms to estimate what the heat should be like for an area. So if you remember Liv's picture from earlier, there's all these different paths everywhere. They run an algorithm to interpolate all the data in between so that you end up getting the full heat map that we're able to see on this website. And then, all this data, it's open source. It really is amazing how much data they have available. So no joint table. So all the data currently that does need to be combined. So the main combination of data is looking at the geography compared to the values. So for example, I might have in this case heat vulnerability index, and I might combine the heat vulnerability index with the boroughs. And I want to actually put the borough name associated with that. So right now, all of that is done on the JavaScript layer, just right on the client side. Looking at all the data sets, the JavaScript side was fine. I didn't find any performance issues or anything that needed to be optimized. For things that did look a little more complicated, and we did have a couple situations that were more complicated, these were from some of the earlier sites, but we were actually able to adjust those layers and make our own layers using QGIS. So again, I saw a bunch of GIS developers. I used QGIS for a lot of the data sets. So originally we had New Jersey, New York. We wanted to combine them at certain times and then later rip them apart. But for both those operations, we were able to do it with QGIS. There were certain data sets that we were able to find in the first iteration that would actually go out into the water, just right onto the border of New York and New Jersey, which is like halfway through the Hudson River, right? So to break that data set up to look cleaner and to look much better on a map, I was able to use QGIS to overlap layers and to just take just the New York City boundaries, which was very cool. Anyone who hasn't worked at QGIS, it's an open source tool, really nice for working with mapping data and for adjusting mapping data. We even use this for something called the NDVI. NDVI is a satellite version of it. Liv was talking earlier about how you might have a park that actually is just asphalt. NDVI does that through satellite images. It's called Landsat, in particular Landsat 8. This is a US government data set that they offer for free. You can take that data set, put it into QGIS, and run a few calculations. So NDVI is looking at the temperature changes across these different satellite images. And using that, you can actually build a layer that gives you an idea for how much asphalt or really not green there is on the ground. That was a really cool technical challenge. So to answer that question, for more complicated data sets, we were able to do some magic with QGIS to build a new data set layer for that particular thing. And there were a few data sets that originally building this site, we just uploaded right to GitHub with everything. These JSONs ended up being on the order of kilobytes, so they really were pretty small. Leaflet, so a really cool technical challenge there. For anyone who has used Leaflet, hovering multiple layers is actually really difficult. So something cool we did for this, we used a Mapbox library that actually looks through multiple polygons and can have multiple layers. So for the machine learning model, Norton's question is, for the machine learning model, did we need the ETL process? Appa, the company that we contracted for the sensor data, they did the machine learning process for us. They just gave us the results of that. That's their bread and butter. That's what we pay them for, is to take sensors and run the machine learning process. Their exact methodology and data sets underneath that, I'm not entirely sure. But if you go to Kappa's website, you can definitely find more information about how they do their machine learning models. So Leaflet, multiple layers, right? When you hover over a layer on Leaflet, to find the layer beneath it is very difficult. So we put in a lot of optimization so it looks pretty smooth when you're going between different polygons. When is that important? When you want to look at the neighborhood name and compare it to a green space, right? What neighborhood is this green space in? Leaflet by default will only give you the top layer because it goes in HTML world. But for this, we were able to use some nice algorithms and again, some nice optimizations to make it as performant as possible. And again, fully config driven, really cool feature of this. This means that anyone coming in can look at a documented configuration, they can add new stories, and they can add new layers in very small amount of time. So I just wanted to highlight, right, being kind of an outsider of this process a little bit, some of the things that were good and not so good for any software developers out there looking to volunteer in this sort of capacity. So some of the really great things, right? We had an amazing team. This was one of the best teams I've worked with on a volunteer project by far. We had great communication. Emily mentioned this as well. It was a very iterative approach. We were on calls together every other week, going through checklists of who could do what, how much time did we have to dedicate. And as a volunteer, that's really important because as a volunteer, you have a job as well usually. So being able to manage the rest of your life with a job with volunteering is really important. New York City's government's willingness to learn and use tech. The team there is not a team of developers, but the amount of development they know really was impressive. They were a great team to work with. Some of the problem-solving pieces here, figuring out the right boundaries for code reuse, right? Where do you put in all the professional software development pieces, but at the same time, where do you kind of pull back, right? Knowing that boundary is really important. Transparency is always a little tough with these projects, and I wanted to highlight that for anyone who gets involved. A lot of the time as a volunteer, you're not actually part of their deployment cycle, right? You're not you don't know everything happening behind the scenes, the strategic plans for the software. That is always a challenge. So anyone who's looking to do this sort of volunteer work, just be aware that happens on every volunteer project. And it's just something you have to go in knowing, and it's a little difficult to navigate that sometimes. Building a complex site with no framework, as I'd mentioned, we used plain JavaScript. That was very cool. It's amazing when you can do a plain JavaScript, especially in a world where React and Vue and Angular are so prevalent. You forget how powerful JavaScript is under the hood. And then iterative documentation as well. We constantly were updating our documentation for this, making sure that, as a volunteer, your goal is always to hand this off, right? You want to help out as much as you can, but always be ready to hand off a project to then go into some sort of public space or back to the company that you're volunteering with. But overall, it's been an amazing project, and we've done a lot of really cool things with it. With that, I'll hand it back off to Emily for the demo.
Thank you so much, Tom. So before we do a demo of this most current prototype, I wanted to give you an update. So as you know, heat season, aka spring and summer, is right around the corner. That means that we may see an uptick in risk for heat-related illness and death. We're almost ready for Heat Story to be live on the portal, where you can look at the data layers and the stories within context of each other. And we invite all of you to submit a story, or if you know somebody who would like to share a story, please let us know. The stories that will appear on here can be anonymous, or they can have as many details as you'd like to add. There's capability to add photo, captions, and various other things of that nature. Okay, so this is what the page looks like so far. We have our map here on the right. We have some data layers here, so you can see the morning heat index, the afternoon heat index, the evening heat index that Liv and Tom were talking about. There's an air quality layer here. There's the heat vulnerability index, which is comprised of a few different factors to kind of indicate what people in what areas might be the most vulnerable to the impacts of heat. And we calculate that using AC access, some socioeconomic factors, vegetative cover, and the actual temperature in that geography, neighborhood, community district, or however you divide up the city. This is a vegetative cover layer. You can see that when you hover over a point, it will tell you that thing right there that says CD, that's community district. That's one of several different ways that we divide up the city for the purposes of gathering data. There's the percentage there, and then it will let you know. In this particular geography, Greenpoint and Williamsburg are combined. We have heat stress hospitalizations, neighborhood poverty, AC access. On the bottom right here, you can see the percentage. And then there is, if you click on this link, you can read a little bit more about that particular data set. And then we also have the redlining maps as discussed here. And then we have the green space data that was taken in northern Manhattan. So for the story part, this is a story that we referred to earlier. You can see this particular account, as mentioned before, Dr. Melissa Barber was mentioning how on Bruckner Boulevard, the heat is exhausting for multiple reasons. And you can see this picture that was submitted without a lot of, green cover. So, just looking at this picture, we can all imagine how hot that feels in the dead of summer. And then you can see that kind of next to this evening heat index. So it's a really nice way to kind of view those personal accounts side by side with data sets about how the impacts of heat are not equally distributed to every part of New York City or every person. And then there's one more story that we'll look at quickly. This is another account. This marker indicates this person gave us a little bit more specific coordinates, which of course you can choose to be as specific or general as you wish. And there's a resource here about fire hydrants and managing that. There's a reset button over here if you'd like to start again. And then you can click on a link here where it says submit a story, and that will take you to our Google form. There's also the project credits, all of the partners that made this possible, and more in depth about the community science data collection and process, and why this particular project, why the methods and results are different from other projects. So we will share a QR code with you all if you'd like to submit something to the Google form. You can also get in touch with us at the health department if you have questions. This is what the form looks like. There's a few other questions, but you can skip them if you don't feel like entering in all of that data. But yeah, here's the QR code. You can get in touch and ask us about the form. If you want to sign up for our newsletter, we'll let you know when this project is live. And now we will open it up to questions. Thanks, everybody.
How does the team think about finding people to submit relevant stories? Are there groups you wish that you could hear more from? Yeah, absolutely. So, I mean, given that the scope that the project began with is Northern Manhattan and the South Bronx, we have reached out, and we will continue to community groups, not just environmental justice organizations, but other civic groups as well, to get more stories for more, to present more granular data from these areas. But we're also going to, now that we are partnered with the city, we're hoping to leverage their reach to get into more corners of New York. Especially because now with the wider data set, the scope is larger. So yeah, environmental justice organizations, other civic groups. There's also a lot of student groups interested in this type of environmental climate justice work. So yeah, we're hoping to expand widely, but that's how we started. And recognizing the close relationships with other disparities. That's why I think we're looking to reach more, groups that work on all these different axes of inequities.
Thank you so much, guys, for such an interesting presentation. I'm currently an undergrad student who's really interested in how rising temperatures impacts older adults. So this is really informative for me. And I honestly didn't even know that this was happening. So I feel really grateful to be here. But I did have a quick question. One thing that I'm particularly interested in is this idea of cooling centers. And I saw that you guys factored in for ACs and vegetation, but I was wondering if that was something that fell into an individual's access to AC. I know cooling centers are typically underused, but they are a way to receive free AC in the city. So I was just wondering if that had any impact or if you guys looked at that data.
I'm glad you brought that up. So I think accounting for the resources available is absolutely important. Right now, on Heat Story as it exists, that is not present. That's not a data set that we looked at. That said, I think that's where we're going to really find these community stories helpful. So even just from the community engagement part, it wasn't just like that one day that we did things together with community members. There was a process to get there. And even in the consultation processes, we found out more about why people choose not to use these centers. So yes and no, and that no, there isn't any quantitative data that we have incorporated into the map right now, but we're hoping that these more granular qualitative stories can be accounted for in the story submissions.
Yeah, thanks so much for that. Just because when I speak to people who go to cooling centers, there are so many interesting stories. So I do think that is an important place. Even places like supermarkets serve as cooling centers. So
absolutely. Yeah. Thank you, Anna. I see Aditi also has their hand up.
Hey, hi. Hi, Liv. Hi, everyone. Thank you so much. I think this is your project was one of my motivation to take up my capstone related to heat mitigation, and I am fortunate to be partnering with South Bronx Unite as well for my project. So my question was that when I look when I look at this kind of maybe the methodology that you've used or the process that you're using, how do you think it's different from what the city has been doing so far? And how do you think that this project could help the city in sort of guide some of the policies or programs, or how do you visualize this could go forward? And this could be probably an early stage to answer it, but maybe just the second overview also could be great.
Yeah, I mean, I can give my take, but yeah, I'll maybe leave it to Emily for the city side of this answer. The overarching goal for us, a really important part of this was to show the overlaps. So I think, going forward, the reason we wanted to show the overlaps between heat and other disparities, say AC access, poverty, green space, historic redlined areas. The goal of doing that was to show that to address heat-related issues, we can't just, address temperature and humidity. We need to think a little more broadly. So I think the contribution that we project from the get-go of the project side we were hoping to make was trying to show these overlaps more visible, to kind of suggest to the city, it might be overwhelming, all these overlaps, but I think we were trying to present this over the complexity as kind of multiple entry points, right? There's opportunity in the complexity because it means multiple entry points. We can address green space, and that's one way to mitigate. We can address social connection. That's another way to mitigate. So that's our side of the answer. But yeah, maybe for the city, Emily, have you guys been in talks about policies forward, how this can inform next steps?
Yeah, I know we want to build out the page with more resources, just more actionable things for people to do, to learn about, to distribute. We want to incorporate more about energy insecurity because it's so closely tied to resilience against heat waves. And we want to just, continue in Liv's vision in kind of adding this human element to data. We think it's really important going forward. As far as how it will feed into policies, that stuff can take a really long time, to be honest. But yeah, we're always looking to, kind of expand how we represent this data for community groups and organizers and people who make policies, people who make decisions. If we can get this kind of stuff in front of them, I think it really makes an impact. But Matthew, if you want to jump in and speak to any of that.
Yeah, I'd like to just great answers, right? And I want to just step back and think really big picture. And one of the things that we want to do is to make this information understandable, right? For anyone who's coming to the site, the issue that heat kills people and that's a crucial issue of climate adaptation for cities is vital, right? And so if we can start to pull this stuff together, right? Like, yes, this information is out there, but the more that we can pull it together and make this information easy to access, easy to understand, easy to use, and show these connections, then the more that this can be like a known fact that's part of the discourse and part of the policy planning.
Yeah, thank you so much.
Thank you for all your questions. We really appreciate it. It looks like we have another one. How do you make sure the data quality, how do you validate the data source quality?
I can speak a little bit to that because most of the data belongs to the Department of Health. Not all of it, right? So Liv talked about the sort of community-based participatory research part of it, but a lot of the other data, the heat vulnerability index, the heat-related illness, emergency department visits and hospitalizations, a lot of that stuff comes from our analysts. And so it actually comes from a variety of different sources. And I'll just let you know that there is a pretty extensive process from the public side of taking these public data sources and going from original source data, right, which might be, hospitalizations data sets or survey data sets for things like AC prevalence, and converting those into sort of clean, reliable data sets. It's extensive. I don't have too much experience with that side of the process, but a lot of times when you see public data sets that are a few years out of date, they're a few years out of date because there is a multi-year process that ensures data quality. And that includes things like deduplicating and, handling errors, in order to get to sort of like tidy neighborhood level aggregated data sets.
How do you think about community outreach to educate folks in vulnerable neighborhoods about this, especially seniors who might not be online as much, and resources for them to access during heat waves?
So I want to start by saying that there is a lot of outreach work already being done by community groups. So I really want to honor that. Groups like South Bronx Unite and We Act, there's a lot of that already. I think there is a need to think about whether, harm results from a deficit of information. So I think a lot of people in these neighborhoods considered vulnerable know about the harms and, know about the multiple pathways in which they are rendered more vulnerable. That said, I will say, sometimes I think the fixes are really simple. So cooling centers, back to Lila's comment, we're actually doing similar studies in Vancouver too, and we're finding that a lot of analog methods are really more helpful in spreading the word. So, a lot of us, especially, particularly in this group, perhaps we might think of social media to spread the word about cooling centers, but actually we're finding that, sandwich boards on the street is really helpful for spreading the word. And sometimes it's like people calling to check in on people, whether that be from community groups or other neighbors. So I know that the city had a program called Be a Buddy program where it was, people from community organizations calling others. That's really helpful. So I think going back to analog ways has been really helpful, but all in the context of, I think a lot of the harm, it's not necessarily that they come from people not knowing about this, but, there are broader things going on too. But of course, information is important to communicate properly. Be a Buddy still active? I believe right now, no. I think there was a pilot program, but I think there are similar initiatives in the works. That's my understanding right now.
Yeah, we do. We have community resilience coordinators doing just like active workshops and info sessions at various community places, whether it's like a house of worship or schools or things of that nature, to as you said, deliver information in person or via flyers or things of that, which I think is quite effective.
Do we have a plan for the long-term preservation of these stories? Yeah, the plan for the preservation of them is to put them in our website and in our site's repository, which is publicly accessible. The plan is for them to be hosted there and stored there.
Thank you guys. Please get in touch, and we really appreciate you attending.